Okay, consider this now. We have a single coil, just one, but it is again connected to an AC source. Because of that AC source, the current through the coil is going to be changing. So current is going to change, which means the magnetic field produced by that coil is going to change as well. Now, since it's producing a magnetic field, like we see the field lines there, that coil is going to experience that same magnetic field. Because it's going to experience that same magnetic field, it's going to experience a flux due to that magnetic field. And that flux, note this is what's important, this is what's different. The flux is due to the magnetic field that it is producing. So it is a self sort of flux. This is where the word self is. And that flux is going to be changing as well. What did we learn from Faraday's law? If a coil experiences a change in flux, then there will be an induced EMF in that coil. Now, what does this mean? It means that the coil, because it is subject to a change in current, is going to induce an EMF, an additional current within the same coil. And of course, if you remember that negative sign in the equation for the EMF, that induced EMF should oppose whatever made the flux change, whatever created it. Now, what does this mean? It means this, very much like what we had when we had the two coils, a primary and a secondary. AC generator, change in current means change in magnetic field, means change in flux that the same coil is going to experience. That change in flux, of course, is going to be proportional to the current. Same thing that we talked about when we talked of two coils, since the magnetic field is going to be mu0 kappa Ni, so it's going to be proportional to the current. So we can write that the overall flux through that coil is going to be a constant. In this case, we are calling it L times the current. And the EMF is going to be the same constant L times the change in current as a function of time. Now, that constant L, when we had two coils, we call it mutual inductance. In this case, we call it self-inductance, or in short, we just call it inductance. What you need to remember is, in addition to everything we talked about here, the direction of that induced current is going to oppose the change in current. That's the minus sign that we have here. Okay, the bottom line. A change in current in a wire causes a change in magnetic field about it. A change in magnetic field results in a change in magnetic flux within that field. Therefore, whenever the current changes in that coil, it induces an EMF in the coil. That process, we call it self-inductance. The induced EMF voltage is proportional to the change in current. You know, I omitted the minus sign here, but L being the inductance of the coil, the unit that we use for L when V is in volts, I is in amps, and T is in seconds, we call it Henry.